Here's an example of a first order decay, first order reaction. Okay. Carbon 14 is converted to not, it's radioactive. Okay. And it's constantly being produced in the atmosphere, and it converts to non-radioactive nitrogen 14 in about 5,600 years. Okay. The notion of this is practical application. This is for determining the age of fossils, using what is called radiocarbon dating. Radiocarbon refers to carbon 14. It's a radioactive atom. Okay. Radiocarbon dating is based on the assumption that the carbon 14 level in living organisms is constant. Um, but once you die, right? So your carbon 14 in your body will start to decay. The level of your carbon 14, concentration of carbon 14 in your body will start to decay, and it's not being replenished anymore. The ratio of carbon 14 then in a fossil to the carbon 14 in a living organism can be used as a way of determining how old the fossil is. Okay? So let's say you had a fossil, you've compared the carbon 14 level in that fossil to a living organism and found that to be 0.25. How old is the fossil? Okay, so ln of carbon 14 in the fossil, right? You can say would be equal to ln of carbon 14 in the living minus kT. Okay, so ln of carbon 14 in the fossil over carbon 14 in the living. I don't know, I'm not writing this well. Carbon 14 in the living is equal to negative kT. So what's the ratio we say of the fossil to the living? It's 0.25, right? Is equal to negative kT. What's our K? If it's first order, what's K? The half-life is 5,600 years. Okay, so that's your half-life for radiocarbon. 5,600 years. So K is ln of 2 over 5,600 years. So what's our K? .693 divided by 5,600. That's 1.24 times 10 to the negative 4, right? 1.24, is that correct? That's 1.2375, so 1.24 times 10 to the negative 4 per year, okay? So I can plug that in here for K, so I can solve for T, the age of my fossil. Is ln of the ratio, which is 0.25, divided by K, which is, what was it? 1.24 times 10 to the negative 4 per year. So that will give me the answer in years. What would that be? Oops. Clear that. So ln of 0.25, 0.25 natural log divided by 1.24 times 10 to the negative 4, and that gives me and that's negative right here, so there's a negative, so there's a negative there. Negative, negative, that becomes a positive number. 11,180 years. Okay? Or 11,000. I'm just going to keep 3 sig fixed. So 11,200 years. Okay? So that's how old the fossil is, based on those assumptions. Now, you could actually have done this in your head because I gave you some nice round numbers. What's 0.25? 1/4. That's 1/2 of 1/2, right? So 5,600 years later, it will be cut to a half. Another 5,600 years, it would be half of a half. You'll have a quarter left. So that means this fossil has lived 2 half-lives of a carbon-14 atom. So 2 half-lives, 2 times 5,600 is, what's 2 times 5,600? 11,200. Okay? So you can work it out using this equation for the first order rate law, or you can just do it in your head, since, like, in this particular case, it's simple because it's a half of a half. So it's a, but if it's not a power of 1/2, the fraction remaining, then you're going to have to use the equation that I gave you here. Okay? Unless you can do that math in your head too.